Due to multiple requests by students, here is a review video on U substitution with two definite integrals at the beginning and then one indefinite. Remember, it's indefinite when it doesn't have the numbers. Okay, so U is always what's in parentheses or what's under the radical. Right, so U here would be 2x plus 7. U over here would be x squared minus 3. Okay, we have to see the derivative of U as part of the integrand for this to work, which here, when we go to find du dx, right, it'll work out. We'll be able to cancel that x out. But anyways, let me not get ahead of myself. Let me focus on one problem at a time. Okay, so next step, find du dx, derivative of U with respect to x, which in this case is 2. Okay, solve for dx. So as often happens, we see just these two flip-flop, right? Du over 2 equals dx. Okay, the difference between the definite and indefinite integrals is that we want to change our bounds. These are currently x values, and we want to change them to u values. So the way that that gets done is you come to where you establish the relationship between u and x, right? U and x are related by this equation. So when x is 1, I come to this equation and I plug in. Okay, so I do 2 times 1 is 2 plus 7 is 9. Okay, then if x is 3, right, go to the equation, plug 3 in for x. That would be 2 times 3, 6. 6 plus 7 is 13. Okay, next I substitute everything for its equal. So I'm going to put an equal sign and continue down here. From here to here, here's the equality. So my bounds are now u. I have u to the 4th. And dx is du over 2. As we get better and better at these, I bet some of you just start immediately saying, oh, that's going to put a half in the front, and then I'll have, you know, just my du. All right, as we get better at these, you'll start to notice little tiny shortcuts that you can do. So the half comes out in front. Then we sometimes forget to find the antiderivative, right? Increase the power by 1, divide by the new power. That's what these two symbols tell you to do, right? This symbol, the s and the du, say integrate me. Okay, so we do that. And we get, so the half stays out in front. We get u to the 5th over 5. And evaluate that between 3 and 13. And directions always say that leaving answers in exponential form and as the sum or difference of two fractions is acceptable. Okay, so we actually have 1/10 u to the 5th. All right, so plug in. All right, and I don't care if you distribute the 1/10 to each term, right? So maybe you have 13 to the 5th over 10, and then 3 to the 5th over 10. I'm going to leave the 1/10 out in front and write it like this. 13 to the 5th minus 3 to the 5th. And don't combine these. This does not combine to 10 to the 5th. Okay, can't combine. Don't put plus c. right? I harped on you so much about plus C, but when you put plus C, that means add any number to the answer and it's still the answer, right? That's not true when we get a numeric answer, right? We can only add whatever number we want to the answer and it's still the answer when we have an indefinite integral. Okay, so this is a perfectly acceptable final answer. Okay, so moving up to the other one that I started, U was, I'm going to have to erase some of this. So hopefully you got all that. All right, so U was x squared minus 3. So du dx is 2x. All right, and we should be getting to the point where we're good at recognizing when things are going to cancel the way we need them to. Okay, I'm happy about seeing this 2x because I know when I solve for dx, that's going to put a 2x in the bottom, and I need the 2x to cancel. And it's kind of convenient that the constant also cancels out as well. Right, I won't even have a constant that I have to pull out in front in this case. And then changing our bounds. Okay, so again, these are x values, which need to become u values. So if x is 2, okay, I'm using this equation right here to find u. Plug in 2 for x, that'd be 2 squared minus 3, u is 1. And plug in 5, so that's 25 minus 3, which is 22. Okay, I'm ready to replace everything with its equal. So moving down here, let me give myself a little more space. Erase. Okay, so plug in substitute everything for its equal. Okay, so I have 1 and 22 are now my bounds. And the 2x, and I've got u to the half. The dx was equal to du over 2x. Right, so probably a lot of you who are getting really good at this didn't even write this, right? You just said, oh, 2x on the bottom, 2x up here, they're going to be gone. Don't even have to worry about it. Okay, now I'm ready to find the antiderivative. I'm ready to integrate. Okay, because I've gotten rid of my x's, I've only got u to the half du. So I increase my power by 1, divide by the new power. Well, don't divide by 3/2, multiply by 2/3. And then this gets evaluated between 1 and 22. Okay, so again, the directions will read, go ahead and leave your answers in exponential form. Okay, so I get 2/3. I don't care if you want to leave that in front or distribute it. So I left, the last time I did an example, I left the constant in front. Oh, I already erased it. Can't go back to it. But so maybe this time I'll keep the constant distributed just so I do something different. Okay. So let's see. I'm going to put this in parentheses. 22 to the 3/2 minus 2/3. Well, let's see. I'm going to get 1 to the 2/3 power, right? Which is just 1. Okay, so I don't even have to put that. So ultimately, my answer is this. Or if you have the 2/3 and then you have parentheses, right? You have 2/3 parentheses, u to the 2/3 minus 1. Sorry, that should be 2/3 minus 1. That is also, or not 2/3, 3/2, sorry. that is also an acceptable answer, okay? Whether you distribute, you don't, your equivalent answers, I don't really care one way or another. All right, so let's come over to this last one. So it's an indefinite integral, which means my answer is a function of x plus c. Okay, as usual, I let u be the innermost function, and I'm looking at that thinking, gosh, I have an x plus 1 in the top. How am I going to get rid of x plus 1? Okay, but how convenient that this, when I find du dx, right, conveniently, I get, because remember, if I can't cancel out that x plus 1, there's no way of manipulating this into getting like x equals something, right? So if I can't cancel out that x plus 1, I wouldn't be able to do this by u substitution. Okay, but when I take the derivative of u, du dx, I get 6x plus 6. Okay, which that will factor. I can factor out a 6, and let's get dx alone. Right, so let's flip-flop places here. And while I do that, I'm going to factor that. So take that 6 right out, and I get x plus 1. All right, so that's how I'm going to get my x plus 1 to cancel, and then be able to proceed with finding the antiderivative. Okay, so I get that equals dx. Okay, so replace everything with its equal. All right, let me give myself a little more room over here. And so as I'm doing this, so let's see, the du gets replaced with, so I have this x plus 1. And again, I'm assuming that some of you are recognizing, okay, that 6, that 1 over 6 goes right out in front. Okay, and then I have u to the 5th, but I have du over, I already brought the 1/6 out front. I have du over x plus 1, those are gone. Okay, those are gone. U to the 5th is downstairs. Okay, anything downstairs, I bring upstairs. So that is u to the negative 5th. I still have these symbols because I have not yet increased the power by 1 divided by the new power. That's when the integral and the du go away. Okay, so sometimes it feels like I've done an awful lot of work when I haven't even integrated yet. Okay, but I get to here. All right, increase the power by 1, divide by the new power. So that would become u to the negative 4th divided by negative 4 times 1/6 plus c. Okay, so when I clean this up, we're not allowed to leave our answers like this with negative exponents. When I clean this up, this becomes, that's a 1. That's a funny looking one. This becomes a coefficient of negative. Negatives belong out in front. Negative 24, and then in the denominator, u to the 4th. Okay, plus c. And then I plug back in for u. So u was let's see, negative 24 times 3x squared plus 6x. So if it's an indefinite integral, you get a function of x, and you have plus c. Okay, definite integrals like the other two, you get answers that are numbers. Okay, and the number that you get is the area under the curve, right? That would be the area under this curve, 2x plus 7 to the 4th, between the x values of 1 and 3. Okay, and the answer you got there was the area under the curve. So again, I hope this was helpful. Thanks.